Hello everyone, welcome back to our channel. So today we are being discussing the today's Codeforces problems A and B. Like I was managed to solve A and B, like still struggling with C. So and I would be like solving C and D, like up solving C and D problem, and I would be posting another video of where I would be solving C and D problem. So for this video, let's solve A and B problem and see how to get them quickly. So let's read the problem statement. So the problem statement is saying we are given with an array, okay, and there is a we need to perform the following operation any number of times, okay, and the operation is we need to select any subsequence, okay, and here is a subsequence, and remove all elements this from the array, and the operation cost this. Determine the minimum total cost required, okay, and here is the module, okay. So by reading the problem statement seems like it would be kind of a bit of a hard problem because we need to find all of the subsequence and there is some modulo operation is written. But frankly, if I tell you, this is actually an easy problem. Like it took me 5 to 10 minutes to just to analyze how exactly I have to figure out the problem. So let's discuss how can we solve this problem. So if you understand the problem, if you have read the problem correctly, you would have noticed that if there is an array, if there is an array that is given to you, and there are some ones, or there are some numbers, here is some one, here is some number, and here is also some one. So what you can see is you can always club these ones to form one subsequence, one subsequence whose cost would always be 1, right? And for rest all of the numbers, all numbers, you could simply add the numbers, because obviously there could be a thing like I could take a single subsequence as well, right? For a single subsequence my cost would be 2, but if I take a subsequence of two positive numbers 2 and 3, my cost would be 6. Else my cost would have been 2 plus 2 plus 3, which would have been 5. So obviously I can say that if I'm taking two positive integers x and y, so my x plus y would always be less than x into y, right? If x and y both are positive integers and greater than 1, like conditions are being applied, so this could always be a case, and so I'm simply adding the integers. And we are taking some of the considerations, like some of the edge cases we would be considering, like if there are all ones, so what we will be doing is we will be maintaining an index idx of the last occurring one, right? And if the idx remain -1, we know that all are 1, so our output would be 1. And if there is some idx for which after there is some ones that exist, so what we would be doing is we would be simply then taking the sum which we have calculated and adding a 1 and doing the modulo. Let me show you the code as well. So if I show you the summation that I've done, so as you can see, what I've done is I've taken a mod value, and what I've done is here rep is the like for loop. I've just like written him as an acronym. So if ai is a positive number, I've simply added the value into sum and doing the mod, and index is I just to maintain the last positive number that I've encountered. If the idx remain -1, so means that there is no element greater than 1. So there would be all ones case. So if n is greater than 0, I would simply be outputting 1, else the output would be 0. Now what we have to do is we need to find a value that if my index is some positive value, right? So there is that after that index, is there any trailing ones after that? If there is a trailing one after that, so what I have to do is I have to simply do sum plus 1, right? So if there is a sum plus 1, this 1 is actually because there could be a trailing one at the last which I have missed, so and I could take it as a part of a subsequence. So now this 1 is added into the final sum, and we have done the mod and we have simply outputted the sum. So this is how we would be approaching the first problem. There is some like a very small visualization that you have to make, only this part you have to visualize it, that how we can optimally like we don't need to calculate for all of the pairs, we just need to do the sums, and like we would be good enough. Now let's see the B problem of the contest. Okay, so the B problem is saying we are given with an array is called good if the difference between maximum and minimum value of the array is this. Okay, and you're given as a permutation, you need to find the number of good sub-arrays in the permutation. Okay, so if I explain you the problem statement, what it is saying is you are given with a permutation of length n, right? You need to take a sub-array, and let's suppose I'm taking this particular sub-array from L to R. If I talk about this particular sub-array from L to R, so what you have to do is you need to find the maximum of this L to R, maximum of this AL to AR minus minimum of AL to AR, and you need to check if that is equals to the GCD of from AL to AR. If this condition is actually satisfied, then you can say my L to R is actually a good subarray. Now here is some mathematics that is actually involved in this problem. Okay, so let's define some of the terms. Let me define a max value as capital M and this particular value as small m, and let's define this as value G, like G as to define as the GCD, right? So what according to the question is that is given to us is capital M minus small m should be equal to G, right? This is what is being given to us, right? Now if I give you a simple statement, if like for k distinct multiples of G, for k distinct multiples of G, wouldn't it would be a condition that my difference of maximum minus minimum should be at least k minus 1 into G, because what I'm saying is if we are talking about some subarray L to R and their GCD is G, so means every element here would be at least divisible by G, right? So if we are talking about k distinct multiples, so what could be the net value? It would be k minus 1 into G. So what I'm saying is my difference to get at least k distinct value should be at least this. This is what I'm talking about. So if this is the case and I know that a capital M minus 1 is actually equal to G, so if I replace it here actually, and G would be greater than equal to 1, so I could simply say my k would be less than equal to 2. So means what I can say is my subarray length that is possible is either 1 or either 2. Now let's understand this both cases as well. So what if I take k is equals to 1? If I take the subarray of length 1, then I'm dealing with some a of ith element, a single element I'm talking about, a single element. If I talk about the single element, then my G would actually becomes to 0 because the maximum value is also a of I, minimum is also a of I, so my G would be 0, which is actually not possible. So in that case I can say if k is equals to 1, my array is not good, right? So what is only left is k equal to 2, where I'm talking about ai and a of I plus 1. So in this particular case I just need to count, what I need to count is minimum of a of I plus 1 minus, sorry, this is maximum, just a second, yeah, just erase this. So here it would be maximum minus, just correct this. So maximum of, let's define this as value x and let's define this value as y. So maximum of f x comma y minus minimum of x comma y should be divisible by their difference. What is the differences? X minus y, like absolute value of this. So if this is true, then I can say this particular subarray of I and I plus 1 is a good subarray. Now why does the difference come? The difference actually came because a of I, if we talk about two numbers, like two numbers and GCD, let's suppose 2 comma 4, so the GCD would be 2. So their minimum value, like the minimum of both of them, would actually decide their GCD. So what we are doing is we are simply taking the difference, and we are taking and we are telling if that is equals to 0, then that would be covering our cases. So if I show you the code of this as well. So here you can see us taken two values, x and y. So minimum of x and y, absolute of x minus y should be equal to count plus plus, and here is the output. So in this particular, like this was also an easy problem. You just need to visualize this particular thing, that my subarray length cannot be greater than equal to 2, and for k equal to 1 it's not possible. I just need to calculate for all of the possible subarrays for length 2. I'm sure you have been able to solve A and B problem, but if you are not, then I guess this video is for you, and I hope you have liked the solution. So please subscribe the channel for more content like this regarding Codeforces, CP and DSA. I would be posting more and more into it, and I would be solving C and D problem after the contest and would be posting their solutions as well. Okay, thank you guys.